Okay. We will study the case when the car here is at A and then at B. Okay, we draw the free body diagram. At A, we have the gravitational force that is downwards, right? And the normal force that is upwards. Okay, but in this case, the center of the arc here is above the point A. So you can see that for the two forces here, the gravitational force must be smaller. Yeah? Must be smaller. So I reduce it a little bit. And maybe to the arrow here must be a little bit thicker. Yeah? This here at A. At B, the gravitational force will be the same, but the normal force can be smaller. Why? Because the sum of them will point down. The center of the curve here is now below the point B. You see? So for A and for B, we have the two situations, two diagram like that. Then you can say at where is the top row? Okay. At A, you have the mg plus na equal to mac at A, right? Then for the from the graph here, you will see the mg will have the negative value, na positive, and here you have mv at A square over r at A, right? R at A is R1. So, yeah, you can get the normal force at A equal to m g plus va square over R1, right? Substitute the value of that. What do you get? The mass of the car with passenger will be 500 kilogram multiplied with the g plus va 20 square over radius at A is 10 meter. So I get here the numerical value of 24900 Newton. Is it okay? Can you check your answer with my answer? Okay, at B, the question is different, but we use the same methods. At B, you have mg plus n minus nb equal to m v at B over R2, right? So in this case, you can see that NB can be 0, right? So the smallest value of NB can be 0. So you see that V will be smaller or equal to V max. So we have to find out the maximum value of V. The maximum value can be, so the equal sign happen when if n at B is 0, right? So V max will be square root of R to G. Substitute the numerical value into that, you have 15 meter multiplied with 9.8. What do you get here? Okay. But do you see something familiar here? Did we have that value before or formula before? A familiar one? Huh? When you look at that, okay, I don't have it anymore. When you look back to the vertical horizontal, her vertical circular motion, you see? Yeah, the smallest force or velocity at top will be R, the square root of GR, right? Can you see that? Square root of GR. Now we have the same, right? But if you compare the two here, you can see that in the case of the vertical circle here, this is the tension, right? So the value here must be the smallest or the minimum one. But compared to this one, the force here is a normal force, right? So this will be the maximum value. So the same square root of RG or LG or something like that. But here you have the maximum value. Another one here, you have minimum value. But the same expression, the same value for GR square, right? Square of GR. Okay, then when it's okay to you, give me the number 4 in the chess box. Number 4, please. We have less people here, right? At the beginning, I have more than 20, but now I have only 16. So the other people will download the video clip and watch it again at home. Okay, another one.